Right now, a machine the size of a small car is hurtling through absolute darkness at 61,000 kilometers per hour. There is no sun in sight, no planet nearby, and it is entirely alone. On November 18, 2026, Voyager 1 reaches a specific threshold of distance. It will become the first human-made object to sit one full light day away from Earth. To understand the physical reality of that gap, look at this map of the distance. It is over 25 billion kilometers. A radio command fired from Earth, traveling at the absolute speed limit of the universe, takes an entire day just to reach the probe. Any reply takes another day to come back. Despite operating across that immense 48-hour delay, the spacecraft is still actively taking commands, making it the most distant remote-controlled object in existence. At 25 billion kilometers out, the Sun is basically just another bright star. Solar energy is essentially zero, which means Voyager has to carry its own internal power source to survive. The probe relies on 3 nuclear devices called radioisotope thermoelectric generators. These convert the heat radiating from decaying plutonium-238 pellets directly into electricity. This chart tracks Voyager's available power over time. Plutonium-238 has a half-life of 87.7 years. Because that fuel is constantly decaying, the total electrical output is permanently dropping by about 4 watts every single year. At launch in 1977, Voyager had 470 watts to run its computers and instruments. Today, those margins are razor-thin. The thermodynamic math is relentless. What started as a grand planetary tour has devolved into a perpetual, desperate game of engineering triage. To manage this steady bleed of electricity, NASA treats the spacecraft like a house with a failing power grid. You turn off the lights in the rooms you don't use, then you shut down the appliances, leaving only the bare minimum running to keep the core alive. The first major sacrifices happened decades ago. After taking the famous pale blue dot photograph in 1990, engineers permanently disabled Voyager's cameras to conserve energy for the long trip into interstellar space. Now, the cuts are much deeper. Engineers are being forced to kill off vital science instruments, like the cosmic ray subsystem, which they shut down in 2025. In April 2026, engineers shut down the low-energy charged particles experiment. The LECP and cosmic ray instruments on the boom are now powered down. This leaves just 2 functioning science instruments to sample the interstellar medium, the magnetometer and the plasma wave subsystem. To keep the central spacecraft alive, engineers have to systematically blind and deafen it to the universe around it. Deep space is cold enough to kill the spacecraft physically, regardless of its data output. Every component relies on the waste heat from the nuclear generators to keep from freezing. If the power drops too low, the internal heaters will fail. If the heaters fail, the hydrazine propellant running to the thrusters freezes solid. And if the thrusters can't fire to keep the antenna pointed perfectly at Earth, the signal is lost permanently. The lengths engineers go to fight this decay are staggering. In November 2023, a hardware failure in the flight data subsystem corrupted a small section of memory, replacing science telemetry with an unreadable pattern of ones and zeros. They couldn't physically replace the chip, so they painstakingly rewrote and relocated the code to a different memory bank. They executed an intricate software patch on a 1970s computer, waiting 48 hours for every single keystroke to confirm. Look at this readout from the Deep Space Network in Madrid. Even catching Voyager's faint whispers requires extreme infrastructure. To download high-rate data from the remaining instruments, they literally networked 6 massive dish antennas together just to hear a single signal. The probe's longevity is a product of durable 1970s hardware being actively sustained by the daily ingenuity of the mission control team. Clever software tricks and power swaps buy time, but they can't stop the absolute physics of plutonium decay. This graph charts the inevitable. Sometime in the 2030s, power output crosses below the minimum threshold to operate. Heaters stop, computers shut down. Internal temperatures plunge toward absolute zero, and the transmitter falls silent. There won't be a dramatic explosion or a collision. Voyager 1 will simply freeze, go quiet, and its active mission will end. But after it goes silent, it enters a new phase. In the vacuum of interstellar space, There is essentially no friction to slow it down. It will just keep drifting uninterrupted at 61,000 kilometers per hour. Researchers calculate it will take trillions of years before it statistically collides with a star. That means this silent machine will easily outlast the Earth, our Sun, and likely the Milky Way galaxy itself. And on its side, waiting in the dark, is the golden record. It is a physical time capsule carrying the sounds of wind, rain, a mother's heartbeat, and greetings in 55 human languages. That fading radio signal marks the conclusion of a machine that lived long enough to become humanity's eternal messenger to the stars.